Cool. Looks like we're live.
Are we?
Yes. So just wanted to welcome everyone to the very first episode of Let's Talk Manufacturing. It's with myself and Scott Moyse from ChipX. We just wanted to have a little bit of a catch up in regards to tooling, different kind of tooling options there are, what ChipX offer, answering some of the misconceptions and some of the questions that people have in regards to tooling, and just wanting to get some feedback from you guys on what sort of information you'd like to see, both on ChipX's website as well as our website, in regards to tooling. So yeah. We may as well get started with that. So if you have any questions, chime in. You can chat directly with us, and we can hopefully answer some of what you've got to say.
All right, so Brett, can they talk as part of the Hangout, or do they have
to? Yes, it looks like Casper Isaacs has just chimed in there. Cool. So does anyone want to kick it off? Does anyone have any questions in regards to tooling to start with? Otherwise, we're just going to ramble on about stuff and hopefully you guys get something out of this. Cool. So Scott, do you want to just go through some of the cutters that you guys stock and for CNC routers, and any questions that you get asked on a regular basis with tooling?
Yeah. All right, I'll just share my screen with you a second. Okay. Screen 2. Send to everyone. All right. So can you see that, Brett?
Yes.
Yeah. So if you want to get to this page from the ChipX homepage, just under cutters here, if you go to all router bits, and they work for other routers as well, not just Vertigo, but we kind of put this heading in here to make it easier for our most common customers. And at the top of the list, we've got two kits. There's a 2 flute kit and a single flute kit. So the best starting point is the 2 flute kit, mainly because it covers the broadest range of materials. And then the single flute kit is a good add-on. So that, in some cases, on the smaller sizes at least, for 3 mil, you really want to be looking at single flute for cutting aluminium. Otherwise, these are great tools for plastics. And the same is true with both aluminiums. Lots of different types of aluminium, actually, apart from really aircraft grade T6 temper type aluminiums, and some of the marine grade aluminiums. They're harder, so they're not quite as gummy. So for both the gummy, softer aluminiums and plastics, you want to reduce the amount of heat that's in the cut as possible. So having a lower flute count allows you to take a bigger chip because there's more space in the flute. And often there's also more, like the cross-sectional area of the cutter through the length of the flute is larger, so it's stronger, and so you can feed it faster, get a bigger chip, and you spend less time kind of rubbing and more time actually cutting the material, get the chips out of there without generating heat. But there are a few other tools in this on this page. There's actually 2 pages which aren't part of the kits. The smaller ball mill here, it's 3 mil, and that's good for engraving. Ideally, having a 1 mil engraving tool would be good. Ball mill would be good, and we will get there. But our starting point here really was to try and sell tools that are going to work right off the bat for people and not just break everywhere. So with 1 mil ball mills and 1 mil end mills, so ball being a full spherical end, fully round, and an end mill being flat with square corners. The smaller diameters are going to be a lot easier to break for new users. Then we've got this chamfer mill here. Although it's called a chamfer mill, it's really a V-bit cutter. So if you want to get into really tight corners, deeper and sharper in your detail. So if you're doing some decorative engraving or something like that, or surfacing an emblem of some kind, then using that kind of tool is pretty good. The next batch, we're actually going to just have like probably a 3/4 of a mil, maybe a 1 mil flat on the bottom, so it won't come to a complete sharp point like that one there does. While it's handy having that sharp point, again, most people end up snapping that off at some soon in the process of using the tool because they're feeding it too fast or they're overloading it. And so while it's nice being able to get a super sharp corner, over time it ends up breaking. And some people get concerned about that. You can just carry on using the tool; it's fine. You just need to redefine it in your cam to have a flat and just try and measure the flat that's been created on the end of it. And then this chamfer mill here is a 90-degree included angle. So this is just if you just want to have a chamfer on your parts to so you don't have any sharp edges on the top face of the part that you're making. Then the other one that's not in there is on the second page here. Is this long one? It's a 3-flute. It's the only 3-flute we sell, and that's you'll see. I'll try and bring up a bigger image of it here. Hopefully, it looks like it's loading. Okay. Anyway, so this has got a total reach of 50 mil, but the flute stops a lot shorter than that. So this is what I call necked tooling, so that the shank has been necked. At the moment, my neck is narrower than my head, so that's why we call it necked. And then it's a 3-flute, so the geometry for this is really targeted at cutting foams, high and low density, but you can use it for other things as well. At the end of the day, it's just a cutting edge. If you've got the tool in the box and it suits the purpose, just use it. And yeah, so you can cut up to 25 mils in one pass. But then you can also cut deeper and reach down without rubbing on the shank. So more and more of our tools will have this necking on them from now on. The latest version of our down cut tool has that as well. The image doesn't show that, but the 2-flute 6 mil. This one here, the down cut. You see that it says the image doesn't really show it, but you see, I won't move my cursor over it, but you can see the flute length is 12 mil, but the length below the shank is 26 mil. So it's necked between the 12 mil and the 26 mil so that you can cut a full 26 mils deep or reach a full 26 mils down without rubbing the shaft of the tool against the job. Yeah, so we'll do that. We'll do that with most of our tools moving forwards because it means that you get the reach without losing the rigidity by having a full flute length. And in most scenarios with the Vertigo, you can't cut. If you wanted 50 mil reach, you can't cut 50 mils down in one pass. You have to do it in several steps. I'll stop. Kevin, we have the power to boot you out. Stop asking silly questions about Imperial. I'll have a look through, see if there's any questions here before I start rambling on about how our tool coding works. We've had a few questions about that before. Yeah, so Casper, I think I covered the 1-flute versus 2-flute. Mark, so feeds and speeds, how do you know it's too aggressive or too fast? Generally, you'll start to hear that well, you'll feel a little bit scared, I suppose, that something's going to go wrong. But that's where the experience comes in, because you can feel like that early on, and when there's actually just fine. Breaking the tool is a pretty good sign that you've gone too fast or too aggressive. But on my machine, I've got an M2, and I can see if I take too big of a cut or start feeding too fast, then I can see that the gantry starts whipping around a bit, and so I have to back it off. Really, it also comes down to what type of cut are you taking. Are you taking a wide width of cut but a small shallow depth of cut, or are you taking a shallow width of cut and a big depth of cut? And so the two really are totally different scenarios, and you can feed more aggressive or faster in one versus the other. And really, it just comes down to what type of geometry you're cutting. And what you're trying to achieve. So just for a simple profile, a 2D profile, I recommend feeding as fast as possible and taking a small step down. And if you're using Fusion 360, you can use the ramp settings in the linking tab to do like a maximum pitch per revolution around the part of 2 mils. So you're never exceeding a depth of cut of 2. But you're taking a full width of cut, say with a 6 mil tool, 6 mil wide cut, and you're feeding at, say, 3,000 millimeters or 4,000 millimeters per minute, and just powering around that profile as quick as you can, and it gradually just works down consistently to the bottom of the cut.
Scott, one thing I get asked quite a lot, or one thing that I see people doing quite often, is plunging end mills into material, and I think that is a big misconception. An end mill is not a drill, and it seems to be quite a common thing for people to do that. And what a lot of people don't realize is it doesn't matter how soft the material is, it's really bad practice to be plunging an end mill into material, and there are really easy ways to get around doing that.
Yeah, so most end mills aren't designed to cut at the center. There are some, and ours aren't. So you have to work your way into the bottom of the hole. You can't just drill straight down, like Brett said. So typically, if you wanted, with our tools, we've got 6 mil cutting diameter. If you wanted to cut a 6 mil hole, then or drill a 6 mil hole, then you can't do that. If you wanted to do an 8 mil hole with a 6 mil tool, you could by using a boring strategy.
Yeah, that's that. Casper's asked that question just now. Casper said, can you talk about the difference between drilling versus bores? Well, drilling is a completely different kind of operation. It's obviously coming down vertically, and there's no sort of extra movement in that. That drilling has lots of different settings, but again, drilling is designed for drills, or you can use drilling operations with chamfer mills if you're spot drilling. That's something that's really good to do if you're cutting aluminium, is to do a spot, especially if you want to drill a precision hole outside of the machine later on, is to use something like a chamfer mill to spot. The other thing is it's really easy to turn the ramp setting on within Fusion or any kind of cam system, so you actually ramp into the material. And ramping in a way can be very useful for getting a clean cut without taking huge step downs. And you can change your ramp angle to the point where you could even avoid having to do different depths of cut or multiple depths of cut if you do a shallow enough ramp angle.
So I can show you some of that stuff quickly in a minute. I'm just firing up Fusion now.
Yep. No worries. Nick has asked upcut versus downcut, when to use either. It depends on what you're cutting and what kind of finish you're trying to get. There are certain materials that it's highly recommended to use an upcut versus a downcut. Things like aluminium, you never want to be pushing the chips back down into the cut. Aluminium obviously doesn't splinter like wood does, But if you were to cut aluminium using a down cut, for instance, all you'd be doing is recutting chips and packing those chips around the flutes. And that's what happens, what can quite often cause the aluminium to melt around the cutter to the point where the cutter will no longer move in the material because it's not cutting material. With a lot of wood, you don't want to be using, like plywood and things like that, and MDF, you don't want to be using an upcut, especially MDF. Carbide cutters quite often aren't as sharp as high-speed steel cutters, and MDF is really well known for tearing, the top layer tearing. So that's where you'll get that tearing or that fluffy effect around the top edge of the cut. You can avoid that by using like a single flute or a 2-flute down cut. But again, with down cutters, you quite often can't cut quite as fast or be quite as aggressive as you can with up cutters, because obviously you're pushing the chips back down into that cut again, so that those chips are just going to be recut and you are going to wear that cutter out over time. So if you're hogging material out or trying to get rid of material as fast as possible and surface finish doesn't really matter to you, an upcut's always a better way to go, would you say, Scott?
Sorry, I drifted off on that last sentence. What were you saying?
That's right. I just said that an upcut quite often is a better way to go if you don't care about surface finish, just because you can be a little bit more aggressive.
Yeah, that's fair. That's a fair comment. Yeah. I'd say with kind of follow on from Matthew's comment about just asking about plastics. I'd always use an upcut on plastics to get those chips out of the groove or the pocket as quickly as possible.
Yeah.
I don't know whether whether it's possible for you to have you got the extractor yet? That might help, but also just like if you can set up like an air blast so that you're blasting air onto the cut as well to flip the chips out, and if they are starting to stick to the cutter and you can't feed the tool any faster, then using compressed air to blow the chips away from the cutting edge would help a lot with avoiding the swarf damaging your part. Also, if you you may not be able to, but some materials, not just plastics, will come with a plastic peel-off sheet on the top. I would cut with that on and then take it off once you finish the part. Yeah, Daniel's just pointed out something with thin materials. Down cuts help push the material onto the table, and when you've only got a thin sheet anyway, packing chips into the cut isn't as much of an issue. So even with thin aluminium, so if you had like 1 or 2 or 1 or 1.5 mil, then you'd get away with using a down cut there because it's going to help you get the job done. But chip packing is not going to be an issue. And you're right, Mark, about I should have mentioned that when I was talking about experience, but anyone who's starting cutting, if you look at the chips or the kind of residue that's coming off the cutter when you're cutting for the first time, if it looks like a powder, like flour, then your feeds and speeds, your spindle speed is either too fast and your feed speed's too slow, or vice versa. So you want to, or you reverse it. So if you want to fix that, then reverse it. Increase the feed speed, and decrease the spindle speed. That means that for every 1 mil that the tool moves forwards, it's going to take a bigger cut. So you're less likely to create dust and more likely to create a chip. Now, in theory, with a 1-flute tool versus a 2-flute tool, you can feed twice as fast with a 2-flute tool than you can with a single flute tool, because you've got two flutes.
Yeah. Casper's asked about lubricants for cutting aluminium. From our experience, and I know Scott's cut aluminium as well, WD-40 seems to work really well. It doesn't burn quite like CRC does. But again, I experimented recently with cutting pastes, and I found cutting pastes work really well. Obviously, you're not cooling the bit down like you would be if you were using WD-40, but if you're cutting nice and fast, then a cutting paste quite often can be a bit better and a little bit cleaner as well than WD-40.
Yeah,
I think it was a CRC brand of cutting paste as well. So I can look that up if people are interested in it. The link for ChipX's website is down in the description as well. So if you guys are wanting to jump over there and you're not sure how to get there, just go down to the description in the video itself, and the link's there. I'm not too sure if everyone realizes, but ChipX have also spent a bit of time and put together a Fusion 360 tool library. That's up the top there. So just download that and then import that directly into your Fusion 360. And they've got a little video. Scott's created a little video on how to do that. Those feeds and speeds that are in there, they are starting points. Is that a good way to say that, Scott?
Yeah, I can't actually remember what I put in there, but it was something safe. Yeah.
Yeah. With routers, and being that the machine doesn't have spindle control or RPM control with the spindle, take a lot of those feeds and speeds as a grain of salt, and that I think your best bet is to feel it out and write down what recipes work and what recipes don't. There's no calculator online that's perfect that'll tell you exactly how fast your spindle should go and how fast you should feed into material. There's lots of calculators that will give you points of entry and starting points, but a lot of that information is fed in there based off big commercial machines that are highly rigid. So obviously the rigidity comes into it massively as well. So start conservative and work your way up from there, and write down what works, what doesn't work, and then just save those tool settings. You can build multiple tool libraries with different feeds and speeds for different kinds of material. So you could just save one as plastic, one as aluminium, one as wood, because quite often you can use the same tools in every kind of material, but you just can't use the same feeds and speeds in all those materials.
Brett, when I share my screen, it doesn't actually show up.
I'm seeing you looking at your screen now.
Yeah, it's not showing up. There's a bit of lag in the feed, I think. Hang
on.
Because before I thought it was my screen that was up, but then I realized it was yours.
No, that's yours.
Oh yeah, it is now. Yeah, I see. Shut up. All right, so I'll just talk briefly about how our numbering system works. You'll see down here there's a skew, and that's also laser etched onto the shank of the tools. Now, the first two letters are the type of tool. So BM is an end mill, is a ball mill. EM is an end mill, and you'll see EMD and EMU. So end mill upcut, end mill downcut. So yeah, it's either 2 or 3 letters. And then 03 is the diameter. The next one is the shank size. So the Makita trimmers come with a 1/4 inch collet by default. You can buy 6mm ones from Makita, but one of the things we chose to do was when we're getting these tools made is to have them put on 1/4 inch shanks and then have metric cutting diameters, so that you're using what arrives out of the box, but you're still using metric cutting sizes. Then the next code is the number of flutes, and then we've got these are actually split into 2. So 06 is the flute length, and then 06 is the shoulder length, so how much it's necked, and then 58 is the overall length of the tool, so from the top to the very tip. So if we're going to have a look at another tool here, we'll go with this one here that we were talking about earlier. So we can see EMD, so it's an end mill, so it's got square corners. It's a down cut. It's 6 mils cutting diameter with a 1/4 inch shank. There's 2 flutes, and it's got a 12mm cutting length. with a 26 mil reach, so it's neck 26 mils above from the tip to the full width shank is 26 mils, and then it's 58 mils overall. And then the description is kind of like an abbreviated version of that in the same order. Yeah, so hopefully that clears things up. We felt like that covered the vast majority of the tools we'd want to make. All right, so has anyone got any questions about that?
I think one thing that we talked about the other day, Scott, was quite often I go around to people's workplaces and houses and see them using their machines. And I've seen a lot of people that cut too deep with a particular tool because they're not taking into account the actual flute length of the tool, and they end up with black marks around the shank. Now, the black marks are probably fine. They're not going to do any damage right now, but what that black mark is the material charring and burning off and ending up on the tool itself, and it's just going to heat up, and then that's just going to create a big glob of mess eventually if you continue to do that. And you're obviously not cutting with the shank. You're only going to be cutting with the flute. So.
All right, so I'll just chuck some holes in this to show what Brett was talking about earlier. Let's check the size of that. I've got 10 mil. Right, so if put some fillets on the corners. Okay, so something really, really basic. We switch across to the cam, create the setup. Want to make sure that our X, Y, and Z are in the right place, and set up our stock to suit whatever. So a lot of the time you'll be cutting your finished part. Your finished part thickness will be the same thickness as the stock you've used. So you want to go 0 on there, and you might have, say, 30 mils of extra around the outside. In this scenario here, you probably want to be setting your coordinate system to one of the corners, and I tend to go for the left front. And then if we just do a normal 2D contour, we'll select our tool. And once you've got the ChipX tool library loaded up, then you can select the tool that you want. So I want to go with this down cut here, do flip down cut. And you pick the edge that you want to machine to. So in this case, I'm going to go down to the bottom edge. And if I just click OK on this, I'm going to end up with a tool path that just plunges straight down. It's got a vertical lead-in radius, a short lead-in, linear lead-in, and then a horizontal lead-in radius, and then gets into the cut. So if we were to simulate this now and turn on our stock, we'll see that it's quite aggressive, straight down, cuts all the way around the outside at the final depth, but it's also leading in and out here. And I've done this a number of times where I've forgotten to turn off my lead-ins and lead-outs. And it's given me a bit of a scare the first time this happened. And it's always worked out fine, but it just doesn't sound great. It makes you jump. So the best way to cut this kind of profile, I find, is on the linking tab here. If you just turn on ramp, and we can set a maximum ramp step down of, say, 2 or maybe 3 mils. And we can put this up to 10. Well, making this much bigger than what you need means that it's going to be limited by the maximum ramp step down here. If I click OK on that, we can now see that for each rotation of the tool around the part, all the way around and back, the distance between these two is no more than 3 mils. Now the other thing is this is starting up quite high, so there's a lot of time being spent cutting fresh air. So you probably want to set your top height. Well, top height's fine. It's at the same height as the stock, and we didn't add any stock to the top of our model. So what this will be is our ramp clearance height here, and that really only needs to be about 0.5 mil. See this toolpath get a lot shallower now. All right, but the thing is although it's ramping down nicely, it's still doing this lead in here, which is fine. It's above the top of the stock, but on exit, it's still shifting sideways and then retracting. So we need to make sure we turn that off. Really, we can just turn off both the lead in and lead out. And then once it gets to the end of the profile here, it stops and just retracts out completely. And so now when we simulate that, you'll see that we start cutting, and you can actually feed the tool pretty fast, depending on the age of which generation of machine you've got from Vertigo will vary what your max feed rate is, but typically anywhere between, depending on the materials, again 2.5 to 4,000, no, 2,500 to 4,000 millimeters per minute is more than acceptable. Yeah, you gradually work to the bottom and get it cut out. Now, these holes are a lot bigger than what we were talking about, but to demonstrate the point, if you select bore here, you can just pick these and you can see straight away that the tool is working its way to the bottom of the hole, instead of just plunging straight down like you would with a drill. So if we can, we've got a 6mm tool, so if we just edit this feature here, we can make the diameter say 7 mils and regenerate this toolpath. We can see that it's doing tiny little circles in here, tiny little helix in here to work to the bottom of the hole. Yeah, so
with bores, something to always note is try and go a little bit deeper than the actual bore depth, so it's sort of by 1 or 2 millimeters, just to clean that bottom edge up is really good practice. And also on routers, and not just on routers, but when you're cutting plastics and wood, even if you get your heights perfectly right, you'll quite often still end up with a little lip at the bottom, and that can be just due to compression on the material. As you're ramping down, you're pushing down on it, and that, yeah. So
to do that, you go in Fusion, you go to the heights tab, and then you've got your bottom height, and you just go negative whatever, how far past you want to go. And so now you can see I'm going 1 mil past. Probably, if you've got a flat bed, then if you flattened your second board, then that's probably too much. But for the sake of see how to do it.
Yeah. Something that might be useful to everyone as well is getting rid of the witness mark, that little entry and exit mark quite often.
Yeah. Okay, so that's done. So what Brett's talking about here is, if we have a look at this toolpath, you're not going to get one on the top in this scenario, but where the tool stops here, it stops right at the end. It stops in exactly the same place as where it started the final pass, and so it can leave a bit of a witness mark on here. And so to deal with that, you just, on the passes tab, you've got the finishing overlap here, and so if we just 1 mil's enough, it'll push past 1 mil. Now the other way of dealing with that is you might want to change your start point, so that's done on the linking tab and your entry position, and here we can pick. We're not going to change the exit. Oh, it does. There we go. Yeah, cool. So it's actually starting off the edge and then coming in, or finishing past the edge. And so we've already cut this radius, and now it's moved straight past it and then retracting. Yeah, so I'll just show you what Mark's talking about here. By default, the color of the stock is based on operation. So if we just skip through to the end, we can see that there's a different color in here as it is out here. But a much more pleasant one is to go to material and go ceramic. We can see a much more realistic material color. And you can make the tool holder transparent as well. Another point here in the simulation is if you just want to check, you can make the stock transparent too. And if you just want to check at a certain point in the toolpath, you can jump straight to that by clicking on the end points of the lines or the arcs. Bear in mind these little white dots don't appear if you have perspective or perspective with ortho faces enabled. They only work with orthographic. All right. Hopefully that's helpful. We didn't really cover lots of different types of tools other than what we sell at ChipX, but the stuff that we don't sell that we may never sell.
Yeah,
things like using maybe a 25mm diameter tool for facing your sacrificial boards. There's certain tools you can buy from your hardware store with it that have 1/4" shanks, which are more than good enough to be able to go through and face your sacrificial boards. Brett may have something to add on that.
Yeah, completely agree with what Scott said. I think the only other tool that is quite useful for a lot of the Vertigo users are corn tooth cutters. Corn tooth cutters, I don't actually have an image up here, but a corn tooth cutter has little teeth all the way around it. It almost looks like a little grinding tool. There you go, Scott will go and Google one for us. Corn tooth cutters are great for composites, so carbon fiber and that. Corn tooth cutters, it's very, very hard to get things like RPM right, because generally what you're doing is you're grinding the material and taking little bits away every time you cut it. It's very much not recommended to use things like upcuts or downcuts with the likes of carbon fiber and fiberglass. Again, those sorts of cutters will end up tearing the material, and you'll probably stall the router very fast. But with something like a corn tooth cutter, that's generally how you would route those sorts of materials. So PCBs, FR4 and that FR1 and that sort of stuff. It's again, those cutters are really cheap and they don't last very long. You'll chew through them really fast, and that's just an unfortunate part about the type of work that they do. Carbon fiber is incredibly harsh on cutting tools and cutting and machines in general. It's just very abrasive. So. Yeah, cool.
You can get really high-end versions of these as well. They're like, if you imagine, they're just like scissors. So they're like up cut, down cut all the way along the length of it. So they chop through the strands as they cut. Well, that's the theory at least.
Yep.
Cool. Just the starting points for materials. I mean, it is quite hard to suggest because it does depend on which Vertigo machine you've got. So really, I normally say start with number 2 on the trimmer, and about 2 meters per minute, and then push up quickly to 3 meters per minute, and just keep pushing and pushing until don't kind of sit at a slower feed rate. And go, oh, that's good. I'll leave it at that. Keep trying to push it so you find the limit of the material you've got and the machine you've got, so that you're making the most out of the tools and not just wearing them out. There was something else I was going to say. I can't remember what it was, but I'm sure we'll be back again at some point.
That's right. So we just want to try and keep this as short as we can. So it's been about half an hour now. We want to try and do these on a regular basis. So this was very focused on router tools. And I know some of you wanted us to cover some other things like feeds and speeds and get a bit more in depth with that. And I think in some of the future videos, we can probably cover some more of that. And the idea behind this is if we can put them on YouTube, then people can come and click the one on router tools and learn all about that. And then we'll do a very similar one for feeds and speeds and posting out to CNCJS and other software like that, and maybe some Fusion tips and tricks in the future as well. So
yeah, I don't ever want to have to prepare for these either. So
no, fair enough.
I'm doing like half hour 45, but as soon as you have to prepare for anything, then it becomes a lot more of a kind of burden. So
yeah,
and the more you guys interact with us on this, the easier it makes it for us to do them. Matthew, I'm flattered. Cheers for the vote of confidence. Lars also isn't the Fusion 360 guy anymore, so he's not part of that team. So you won't see any more Fusion 360 videos from him anytime soon. Unfortunately for the beginners. Yeah. Anyway.
Cool. Well, thanks everyone. And we've decided to name this cast Let's Talk Manufacturing. So we won't just be covering CNC tooling and software and things like that. I hope to go over all things manufacturing and sort of desktop manufacturing, just to help move you guys along and give you guys some of the information and things that we've learned over the years. And yeah, but again, ask questions. That's the best way for this to work. So cheers.
Have a good evening, guys. See ya.